Here's a quick video on how to do this type of equation, which my current year 11s are finding quite tricky. So we've got 64y to the minus 4, and 4 to the 5 over 2, and 16 to the y plus 7. Whenever you see these types of equations where you have numbers to a certain powers, you want to try and look at changing the base, i.e. changing them all to the same number that you're going to have to the power of. And what we can see is 64, 4 and 16 are all powers of 4. They're also all powers of 2, so you could just do it to the power of 2, but we'll do powers of 4 here. So 64 is just 4 cubed, so we got 4 cubed to the power of y minus 4, and we got 4 to the power of 5 over 2 times by 16 is 4 squared to the power of y plus 7. Multiply these out, we get 3y minus 12, because you've got power of a power, you multiply them, equals, let's just leave this one for now, times by 4 squared power of y plus 7, just times them again, so you get 2y plus 14. I missed the y out. And then we want to combine these two, because what we want is we want 4 to the power of something equals 4 to the power of something, and then it becomes easy to solve. So when we are timesing these, we must add our indices. We must add 5 over 2 to this. So we're going to get 4 to the power of 2y, 5 over 2 added on to 14. Well, 5 over 2 is just 2.5. I think most students would rather write 16.5 than that as a fraction. So what we've got 4 to the power of all of this, 4 to the power of this. So these two things must be equal. So 3y minus 12 must equal 2y plus 16.5. Take away 2y from both sides, you get y minus 12 equals 16.5. And then add on 12 to both sides, so y must be equal to 28.5. And there we have our answer. So what you're going to do is make sure you get all the bases the same. Rearrange so as you got whatever the base is to the power of something, that base to the power of something. Then solve the equation.